We all think we've got numbers figured out. 1, 2, 3, maybe a fraction here and there, or a negative number. But what if I told you that the number line you learned about in school, that's just one piece of a much, much bigger picture? Today, we're stepping off that line and into a whole new dimension of numbers. And this whole journey really starts with a simple question. What happens when the rules of math as we know them just stop working? When you run smack into a problem that seems to have no answer at all? Well, it turns out there's a really famous wall in basic algebra. It's a kind of mathematical dead end, and it's built from one single, seemingly unsolvable equation. Here it is, x squared plus 1 equals 0. Now, think about to algebra class for a sec. To solve for x, you'd move the 1 over, right? And you get x squared equals -1. And that's the wall. Because, in the world of real numbers, the numbers we use every day, you can't multiply any number by itself and get a negative. It just doesn't work. A positive times a positive is positive. A negative times a negative is, well, it's also positive. So this equation? It's impossible. A total dead end. But you know what? Hitting a wall like this is nothing new for math. We started out with just natural numbers for counting stuff. Then we needed negative numbers, so we invented integers. Then we needed fractions, so boom, rational numbers. We needed to handle things like pi, so we came up with real numbers. Every single time we hit a wall, we just imagined a bigger universe of numbers to get around it. So what are we going to do about this wall? Well, to break this one down, mathematicians did something just absolutely brilliant. Instead of giving up, they imagined a solution into existence. They basically created a brand new dimension in our number system. And they gave this new thing a simple name, I, which stands for imaginary. They define I with just one single powerful property. I squared equals -1. That's it. I is simply the number whose square is -1. It's the key that unlocks this entire problem. And I want to be clear, this isn't just some clever little trick. This one single idea, it's like a seed. Once you really get it, an entirely new mathematical universe just blooms from it, turning all those dead ends into wide-open highways. Okay, so let's dive into this new world and see what these numbers actually look like. They're called complex numbers, and they're really a combination of the world we knew and this new one we just imagined. So, every complex number has two parts, almost like coordinates on a map. You can see it in the table here. First, there's the real part, A. That's a number on that good old number line we're all used to. Then there's the imaginary part, B, and that tells us how far to go into this new imaginary dimension. So, for our example, z equals 3 plus 4i, the real part is 3, and the imaginary part is 4. Simple as that. And here's a neat little detail. If a number has no real part, if a is 0, we call it a purely imaginary number. It exists only in that new dimension we just unlocked. Now, you might think navigating this new world is going to be complicated, but it's surprisingly easy. What if you want to add two complex numbers? It's so straightforward. You just add the real parts together, and then you add the imaginary parts together. You just keep them separate. That's really all there is to it. Okay, addition is a piece of cake. But what about division? Yeah, dividing by a number that has an I in it can get a little messy. To clean it all up, we need this really elegant tool, something called the conjugate. So here's the issue. The big problem with division is that we really don't want an imaginary number hanging out in the denominator of a fraction. It's just not clean. So the question is, how do we get rid of it? We use its secret weapon, the conjugate. The conjugate of a complex number is basically its mirror image. All you do is you flip the sign of the imaginary part. So the conjugate of a plus bi becomes a minus bi. That's it. And here is where the magic happens. Check this out. When you multiply a complex number by its own conjugate, the imaginary parts, all those I terms, they completely cancel each other out. And what you're left with is always a simple, clean, real number. This is how we tame division. All right, let's bring it all together. We've got this new type of number, we've got the tools to work with it, so it's time to go back to that wall we smashed into at the very beginning. Remember this old friend? The equation that seemed totally impossible? X squared equals -1. Before, we were stuck, but now we have the key. The solutions are x equals I and x equals -I.
And just like that, with one simple imaginative leap, the unsolvable becomes solvable. The wall is completely gone.
And look, this is way bigger than just solving one tricky little equation. This is a huge deal. What we've really unlocked is a system that contains all the other numbers, and it gives us the power to solve all sorts of equations that used to be impossible. And this imaginary idea, it's absolutely essential for describing very real things, from the electricity in your walls to the strange world of quantum physics. It's literally the language we use to design modern electronics and process the signals for your phone and your Wi-Fi. Which really leaves us with a final thought, doesn't it? If just imagining the square root of -1 could open up an entire new dimension in how we understand the universe, well, what other impossible ideas are out there just waiting for someone, somewhere, to imagine the right number to make them real?